Lesson 28, session 2. We're going to be exploring more problem solving on the coordinate plane using x and y coordinates to figure out distance, usually traveling up and down vertical lines or left and right on horizontal lines. In this first problem, we have a competition with robots, and the robot's been programmed to move specific locations. It'd be very helpful to kind of sketch in a coordinate plane. It doesn't have to be exact, just enough to be able to count correctly. Madison competes in a robot challenge. For one task, she programs her robot to move to locations on a grid. The robot picks up a ball at a point A, which is at -6, 3, and moves it to the first point B at -6, -4. And then from there to the point C, -2, -4, and it always goes in straight paths. Each unit on the grid represents 1 foot, and we want to know what's the total distance Madison's robot moves with the ball. Okay, so to kind of get a concept of this, we're going to start at point A, which would be -6, 1, 2, 3, 4, 5, 6, 3, so about right here. This is the point A, and then it's going to move to point B, which is at -6, -4, 1, 2, 3, 4. It's going to move straight down to here to point B. And then it's going to move to the point -2, -4, which is right here. Okay, so it moves. Let's do the path here. It moves down this way and then to the right this way. And the question is, how far is it moving that ball, right? So there are a couple ways to do it. We want to be able to use absolute value to show this with an expression, but also we could just sit here and count along the axes to figure out how long that's going to go, right? So for instance, let me use a different color here to show all of this. All right, here we go. So the distance from here to here would be, let's see, 1, 2, 3, 4, 5, 6, 7. And then the distance from here to here would be 1, 2, 3, 4. So the distance traveled would be 7 plus 4, which is 11, right? But there are some other ways that we need to be able to express it, to check our work. Again, there's multiple ways to think about things, and kind of my job as a teacher is to show you different ways to think about things. This way works just fine. It's a distance of 7 going from A to B, and then an additional distance of 4 going from B to C, all right, which is a total of 11 feet that this ball will be taken, all right? And you can kind of look at, the other way to look at this is between points A and B, the x values are not changing, right? Only because it's moving up and down. And that kind of makes sense that we're only going to be moving up and down. That's only going to change the y values. Moving from 3 to -4, that is a distance of the absolute value of 3 plus the absolute value of -4. Because remember, absolute value is distance. And because these points are in different quadrants, we are going to add those distances, right? 3 plus 4 is 7, right? Which is where we got the 7 from, okay? Moving from the points B to C, the y values are staying the same because we are making a horizontal movement. We're only moving x values. We're going from -6 to -2. Now, those are in the same quadrant, right? That we're not moving from a positive to a negative or a negative to a positive. We're going from -6 to -2. So the absolute value of a -6, that's the distance to there, to -2, because these are not changing sign, we actually are going to subtract those. That's going to be 6 minus 2, which is equal to 4, right? Which is where we get this 4. We add up those distances to get a total distance of 11, right? On your next couple of pages, it does go a little bit more into detail there. 3 plus 4 is 7. That's the distance from A to B. And then the distance from B to C is 6 minus 2, right? Which is really 4, right? That's this distance right here. And then I kind of already went through this page. You'll notice that the x values are the same between A and B. But because we're going from 3 to a -4 on our y values, up from 3 down to -4, we are going to add, because the signs change, we're going into different quadrants. We add those distances, or we add those absolute values, which comes out to 7. And then from B to C, we stay in the same quadrant, right? We're moving horizontally because of our y values staying the same. We're not moving up and down, we're just moving left and right along the x-axis. These are staying in the same quadrant, though. We're not changing quadrants, so we're going to subtract those distances. It ends up being 6 minus 2, looking at those distances of absolute value. And so we had a total distance of moving up and down 7, and then left and right 4 for a total distance of 11. Okay, I'm going to skip a couple of this because I've really talked about these questions. If you have time at the end of this video, come back and answer these questions. I do want to focus on questions 3 and 4. Why did we add the distances between A and B? Well, remember, we add these distances because they're in different quadrants. Okay, we're going from a positive 3 to a negative 4. And anytime we're changing those signs, we're going to add those distances. Okay, and then why did we subtract from B to C? Well, that's because we're staying in the same quadrant. We're going from this negative 5 right here, sorry, negative 6, to the negative 2. Because we're going from a negative to negative, we need to subtract those distances. Okay, we're staying in the same quadrant. All right. Moving on here, I'm going to skip these. Again, if you have time at the end of the video, after the video, come back and answer these the best you can, okay? Number 8. It tells us to reflect point B across the x-axis. So we need to cross this axis here. Okay? So if we're going to reflect, remember reflection just means same distance, and right now it is a distance of 3 from the x-axis. So we're going to go 3 in the opposite direction, staying on the same vertical line. We are going to make this point and label it C. What is the distance between B and C? Well, the distance between the x-axis and B is 3, and the distance between the x-axis and C is 3. 3 plus 3 is equal to 6. So the distance is 6. If I had to write an absolute value equation, though, for this, it would be, because we're going from B, which is at the point 1, 3, and I'm reflecting to the point C, which is at 1, negative 3, we are switching quadrants. You'll notice that our x values are not changing, but our y values are. Because we're going to a different quadrant, we are going to add those absolute values. The absolute value of 3, right, plus the absolute value of negative 3, which is really just 3 plus 3 again, which is equal to 6. Just remember, this is kind of a reinforcement of what we know about absolute value, being the distance from 0, which is where we got 3 and 3 over here. What is the distance between these 2 points? Well, again, yes, we can just count on a grid, right? But if we start getting bigger numbers or more complex numbers, it's not going to be as easy to see on a grid, on a coordinate plane, right? So what are the distances between these 2 points? Well, the y values are the same, right? So if you think about this, trying to picture that, the y values are up here at 6 for both of these points. One's over here in the second quadrant, and the other one's over here in the first quadrant. They're on the same horizontal line, but just in different, x values, x positions, right? So because the y values are the same, and because we're moving quadrants, we're going from a negative side, quadrant 2, to quadrant 1, we can actually add those distances. The distances can be found by looking at the absolute value of 8.5. That's how far it is from the y-axis, plus the distance it is to 5.5 in the first quadrant. Well, that's just going to be 8.5, right, plus 5.5. And we add these up. 8 plus 5 is 13, and then the 0.5 plus 0.5 is 1, which is going to add up to be 14 units away from each other. Okay, we're going to go ahead and skip this exit ticket. Again, if you got time at the end of class, go work on this, okay? I'm going to jump up to number 1. It says that point L is located at 4, negative 1. 4, negative 1 would be right here. Plot point L, so that's what we've done. Explain how to use absolute value to find the distances between point L and K. Well, L and K are in the same quadrant. So we're going to be finding the distance. Again, it's not too bad to do, well, the distance is 1, 2, 3, right? So the distance is 3. But how do we use absolute value to find it? Okay, well, the point L at 4 comma negative 1, the point K at 4 comma negative 4 are have the same x value, right? Let me grab my highlighter for a second. They have the same x value. Okay, that means that they're staying here, they're only moving up and down. 1 is moving from -1 to -4 on the y-axis. Because they're in the same quadrant, because it's going from a negative to a negative, we are going to look at the absolute values of those, the distances, but because they are the same sign, negative to negative, or they're in the same quadrant, in this case quadrant 4, we are going to subtract those distances. Okay, that's going to be 1 minus 4, which you might think, well, is -3. But again, we're talking about distance, right? So really, maybe we should have put the further one away first. The biggest distance away minus the smallest distance away, which really is just 4 minus 1, which makes more sense. So the reason why I wanted to talk about this one is sometimes we set up our problems backwards, and then we kind of make sense of it after the fact. It doesn't make sense for distance to be negative, so this is the incorrect setup, okay? Always start with your bigger distance and end with your smaller distance, because distance should always end up being positive. We want the bigger number minus the smaller number. All right, so that's how we can use absolute value to figure out how far away those points are. Up here on our grid, we could have easily said, hey, K is 1, 2, 3, 4 away. L is 1 away, so they must be a total distance of 4 minus 1 away, which is a distance of 3. That's basically what this is trying to say here for us, right here. Okay. I'm going to skip number 2 for now. Let's move on up to, we're going to skip number 3 as well. Number 3 is really tough. If you want a challenge, give that a shot. Number 4 is just distance between 2 points again. It starts off by saying what quadrant is F in. F is at -10, 12. -10, 12 would be -10, 12 would be up here somewhere, so that's going to be quadrant 2. What quadrant is point G in? Well, that's at 18, 12. That's going to be 18, 12 right here, right? That's quadrant 1. So going from F to G is changing quadrants, and because of that, that means we can find their distance by adding those absolute value distances, right? Will we be using the x coordinates or the y coordinates to find the distances? Well, because the y's are the same, right? Because the y values are the same here, their distances can be found by looking at their x values. So we will be using the x coordinates to find their distances. What is the distance? Well, look at their x values. Which one's further away? Well, 18 is. The absolute value of 18 minus the absolute, adding the absolute value of -10. That's going to be 18 plus 10, which is 28. Again, we are adding the distances because we are going from quadrant 2 to quadrant 1. Okay, that's the distance. In this case, it wouldn't have mattered if you put the absolute value of -10 first, just because we're adding. When you're dealing with points that are in the same quadrant, though, definitely make sure that you're putting the one that's further away first minus the one that's closer to the axis. Okay? Anyway, that's it for these. Let me check my last one here. I think we're good to go, though. Yeah, you can probably do this on yourself. This one is not too bad, though. Go ahead and try to do this one all by yourself. You're basically just have to find the correct answer. Which of these is true? There's only one answer. Looking at all these distances and comparing them, go ahead and find the right answer for that one. Make sure your notes are good to go. If there's more time in class, guys, please make sure that you're going back through and answering the questions that we didn't answer together. Just do your best. Get your brain thinking. Keep it busy. And I'll see you next time.